Good day, everyone. Today I will walk through the sample problem number 1 on material balance in drying. So the problem states materials enter a dryer containing 60% of water and leave with 5% water. Find the weight of water removed based on 1 pound of original product and 1 pound of final product. Then letter C for 1 pound of bone dry material. So K data. Initial moisture is 60%, then final moisture is 5%. So our goal is to find water removed using 3 different bases. So let's assume 1 pound of wet materials enters 60% of that is water. So 0.60 times 1 is 0.60 pounds of water. Then the rest is bone dry solid, which is 0.40 pounds. Then at 5% moisture, dry solids is equal to 95% of final product. So 0.95 multiplied by final product, which is 0.40, is equal to 0.42211 pounds. Then the water left is 0.05 multiplied by 0.4211 is equal to 0.0211 pounds. So the results water removed is we need to subtract 0.60 into 0.0211 is equal to 0.5789 pounds. So now let's assume the final product 1 pound of water in it 5%. So 5% is equal to 0.05 pounds. So the dry solids is 0.95. Then to get the original weight, dry solid is equal to divided by 40% is equal to 0.95 divide 0.40 is equal to 2.375 pounds. Then the 60% of it is the initial water, which is 1.425 pounds. So the water removed is 1.425 minus 0.05 is equal to 1.375 pounds. So for that 1 pound bone dry material, since the dry solids are 40% of original, so original weight is 1 divided 0.4 is equal to 2.50 pounds. Then subtract by 1, we can get the answer of 1.50 pounds. So the final product dry solid is equal to 95% final weight divided by final weight, which is 0.95. So we can get the answer of 1.0526 pounds. So the water left 1.0526 minus 1 is equal to 0.526 pounds. So the water removed is 1.50 minus 0.526 pounds from the water left is equal to 1.4474 pounds. So in number 2, a rotary dryer produced 20 metric tons of dried sand with 0.5 moisture from wet feed with 10% moisture. So wet sand enters at 30 degrees and leaves at 115 degrees Celsius. So the fuel consumption is 275 liters per hour at 39,000 BTU per liter. So the CP of sand is just 0.21 BTU per pounds per degree Fahrenheit. So find the dryer efficiency. So dryer efficiency is equal to useful heat divided input. So first, the total heat supplied by the fuel is 275 liters per hour multiplied by 39,000 is equal to 10,725,000 BTU per hour. So the heat absorbed by the sun, I convert the 20 metric tons per hour into pounds per hour. So I just multiplied it by 1,000, then multiplied by 2.204, so we can get the answer of 44,092.4 pounds per hour. So the next is the temperature. 85 times 9 over 5 is equal to 153 degree Fahrenheit. Then Q, we can use the formula of heat, which is Q is equal to mCp delta T. So everything is given except Q, because Q is what we're going to find. 44,992.4 multiplied by 0.21 multiplied by delta T, which is 153 degree Fahrenheit, is equal to 1,416,596 BTU per hour. So the dry solids in the final product are 44,992.4 multiplied by 0.995 is equal to 43,872 pounds per hour. So the wet feed becomes 43,872 divided 0.90 is equal to 48,747 pounds per hour. So the water entering is 10% of 48,747 pounds is equal to 4,877 pounds per hour. So the water remaining in the product is 44,092.4, then multiplied by 0.05, so we can get the answer of 220 pounds per hour. So therefore, water evaporated is equal to 4,875 minus 220 is equal to 4,655. So the heat required for evaporation, 4,655 multiplied by 970, so the answer is 4,515,350 BTU per hour. So the useful heat is the sum of the heat absorbed by the sun and the heat used to evaporate moisture. Therefore, 1,416,596 plus 4,515,350 is equal to 5,931,946 BTU per hour. So the dryer efficiency is we just need to divide the total over heat input multiplied by 100. So 5,991,946 divided by 10,725,000 multiplied by 100 to get the efficiency of 55.3% rather. So that's all.